Okay, so in this lesson, I'll let you read it for yourself. It says x-intercepts of a parabola. Well, I guess we're going to see what x-intercepts are in case you forgot what they are in grade, let's see, that'd be grade 10. But in grade 11, we just have to look at this, and we're going to start by just graphing it, okay? So with a graphing calculator, graph y equals x squared minus x minus 12. So let's pull our handy-dandy graphing calculator over. And let's do this. Turn the calculator on. Don't forget to reset it. If you see something there already, just reset it by going second function plus sign 712. It just resets it completely. All right, I'm going to make this a little bigger so that it's nicer to look at. All right, that should do a little bit bigger. There we go. That looks better. Okay, push y equals. Go to x squared. Remember, there's the x button. X squared minus x minus 12. Then we're going to hit graph. There it is. It's not perfectly on the screen, but it's close. And it says, using trace, type in numbers for x until you find the x-intercepts of your parabola. Write them down. Okay, so let's do that. X-intercepts, remember this is the x-axis right here, and an x-intercept is where this graph, or this quadratic equation, where it cuts through the x-axis. So there's one right there, and there's another one right there. Okay, let's see if we can guess what they are. I see 1, 2, 3 ticks to the left. So let's type in -3. Well, first push trace, then -3, hit enter. Sure enough, we're right there. Okay, y is 0 right on that line. It's perfect. All right, so that's the first thing we should write down. I'm going to write it down right now. -3. X is -3. Okay. Then go back to our calculator and let's guess what the other x-intercept is. 1, 2, 3, 4. Let's see if it's at 4. 4. Hit enter. Sure enough, y is 0, which is perfect, which means it's exactly on the x-axis when y is 0. Okay, and x is 4. So we just write that down right here. X equals 4. Okay, can you remember that? I'm going to write them down again. Remember, we'll just go back when we do the next part. The two intercepts were negative when x is -3 and x was 4. Okay, if you wanted to, you could write that like this by writing it in the coordinate pairs. -3 and 0 is the first x-intercept. The other x-intercept is 4 and 0. That's just another way of writing it. It's showing the coordinate pairs. It's exact spot. Okay. It says now factor this. Remember, this is the exact equation that we just did on the graphing calculator right here. We're supposed to factor this using the factoring that we've been doing, that you've learned. Okay, so I'm just going to start by putting those brackets to factor it. Remember, we put the x right here, we put the x right here. What two numbers times to make 12? Actually, -12. Don't mind the intercom announcement in the background. So what two numbers times to make -12 and add up to make -1? There's an invisible 1 there. Well, first of all, when I think 12, I think 6 times 2. That's not going to work to add to make a -1. But my next thought is, what about 3 times 4? Well, definitely that's going to work. 3 and 4. One of them has to be positive and one negative. Well, we want them to add up to make a -1. So if we want it to be negative when they add up, you should make a +3 and a -4. You put those together, you get -1, which is exactly what we wanted in the middle here. If you times them together, 3 times -4, you get -12. That's perfect. Okay? Now, do you see something similar to what we found using the graphing calculator? We have a 3 here, and we have a -4 here. Let's go over and see. Over here we have a -3 and a 4. It's almost the same thing, only notice the signs are different. Here's a -3 and a 4 there. Well, the answer on the first page was totally right. So the reason why the answers are totally right is that we are actually looking for a spot. An x-intercept is always something that is on the y when y is 0. So when y is 0, that's when we get our x-intercepts. Okay? Remember, with our parabola that we just looked at, actually I can just show it right here. There it is. Notice how y is 0. Okay? So that's why I'm just putting a 0 there where you see the y. And if y was 0, what we could do is say, how could y become 0? Well, either this is this times this, right? So if one of these was 0, that would make the whole thing 0, because 0 times anything is just 0. So that might be a bit confusing. So what I want you to do is just say, okay, what does x have to be in order for this to be 0? What does x have to be in order for something plus 3 to be 0? Well, x has to be -3, because -3 plus 3, and then you have, it doesn't really matter what you have over here actually. I'm just putting the -3 twice. -3 plus 3 is 0, right? And 0 times anything, it doesn't really matter what this is here. It's -7 if you really want to think about it. But 0 times -7 is just equal to 0. Okay? So really what we were looking for is, what is x? What is the x-intercept? Well, in order for this thing to be 0, this x has to be -3. And that is the answer that we got using the graphing calculator. If you don't like what I just said, I'm going to erase all that. Okay? Just think to yourself, what does x have to be in order for this whole bracket here to become 0? -3. So x has to be -3. Anything else? Well, if you wanted to, x could be something else as long as this side became 0. Because 0 times this will still be 0. So what would this x have to be over here in order to make this thing 0? Well, as we know, 4 minus 4 is 0. So if x was 4, that would also make this whole thing 0. So there's two x-intercepts. X could be either -3 or x could be 4 in order for this whole thing to become 0. You can write it like this if you want. X equals -3 for one of the intercepts and x equals 4 for the other intercept. But you just keep going like that. Let's try another question, because the more practice, the better. So this one says to just find the zeros or x-intercepts just by factoring. It doesn't really say factoring, but we're going to factor. And then we'll see if the graphing calculator gets what we get. Okay? So let's try this out. Remember, just like the lesson before this, divide everything out by what you see as the a value right here. Get rid of that 4 first of all if you can. Sure enough, all of these will be able to be divided by 4. Okay? So what's left? 4x squared divided by 4 is x squared. 4x divided by 4 is x. 168 divided by 4. I don't know what that is off the top of my head. I'm going to stick it on my calculator here, and I can see it's 42. All right, let's factor this. Okay, what two numbers times to make 42 and add to make +1? Well, if you know your times tables, you'll know right away. It's 6 times 7. 6 times 7 makes 42. We want a -42. So one of these has to be negative, and one of them has to be positive. Well, let's make the 7 positive and the 6 negative, because when you put them together to add them up, you'll just get a +1 for the middle part here. All right? So there's our two answers. Now, if you remember, what the graphing calculator will show us as the x-intercepts is not -6 and 7. It's the opposite of -6 and 7. So your final x-intercepts should be x equals 6 Remember, it's whatever this is to make it 0. So 6 minus 6 would be 0. And the other x-intercept is x equals, what's the opposite of 7? Negative 7. Here is our two x-intercepts. Let's graph it and see if we get the same thing. Okay, so I turn it on. Turn the graphing calculator on. There we go. Push y equals, clear that. Now we had 4x squared plus 4x, what is it, minus 168. Minus 168. Okay, let's graph it. Okay, the graph we see here is obviously a parabola going way down and coming back up. We could zoom out and we could push zoom and zoom out and see this properly, but we're not really concerned with the parabola as a whole. What we want to know is, what are these x-intercepts? Let's see if they match what our answers were. Push trace, and then what did we get? We got 6 as one of our, so I push 6. Sure enough, look at that. There's the x-intercept at 6 and y is 0. Okay, perfect. The other one we got behind this calculator is negative 7. Okay, so let's type in negative 7 and see if we get it. Negative 7 for x. What happens with y? Look at that. It's blinking right at the right spot. And that's perfect. So we just came up with the x-intercepts by factoring here, folks. You can do it on the graphing calculator. Whoops. The graphing calculator, or you can do it by factoring. Okay? Let's try some more of these, because you can always push stop if you understand what I'm talking about, but those of you that want to keep practicing, let's keep practicing. What's the first step in order to factor this thing? Divide everything by negative 3. Okay? Let's do that. 24 divided by negative 3 is negative 8. Don't forget the x. And negative 48 divided by 3 is what? 16. Okay? It's a negative 3, and you're dividing a negative 48, so be careful. Your answer is a positive 16. If you're not sure, if you make a mistake there, just think negative 3 times 16 has to give you negative 48, and it does. Okay? So negative 3. We're going to factor this now. We're getting lots of practice factoring. And I'm doing it a little quicker now. 4 times 4 is 16. And I want them to add up to make negative 8. So I'm going to make it a negative 4 times a negative 4. And there we go. We could write it like this if we wanted to, but we don't have to. We could go like this. That is also cool, because squared just means this times itself. Okay, but we don't have to do that. Alright? So this graph's a little different. Our x-intercept is going to be whatever x is to make this thing 0. What is x going to be? Well, x is going to be 4. Okay? What will it be for this side? Well, it's the same thing, so x is going to be 4. Okay? Now that's a little different. That means that this thing has, it's kind of a debate. It seems to have only one x-intercept, which is x is 4. So it's kind of weird. Some people have explained it saying, well, it kind of comes around, the graph's going to come around and touch the x-axis at 4, and it's going to kind of tap it twice at 4. But whatever the case, let's look at the graph and type in this equation. Let's see, there we go, we can fit it all in perfectly here. Push y equals, clear it. Let's type it in. Negative 3x squared plus 24x minus 48. Let's hit graph. Okay, no surprise, the graph is opening upside down, or it's opening at downwards. It's got a maximum, it's negative, because of that negative sign in front. Now, let's type in what we got as our x-intercept. So push trace, and let's push 4, because that was our x-intercept. Look at that. It's exactly at that spot right there. That is the x-intercept for this parabola. X equals 4. Okay? Let's move to the next question. It says, y equals x squared minus 8x. Is there anything we can do here? Well, sure enough, we can factor out an x. So just go like that. What's left? Well, you get x minus 8. Okay, we just factored it out. Factored out the x. X times x is x squared. X times negative 8, negative 8x. All right, is there anything more we can do in here? Is this a difference of squares? No, it's not. That's it. We are done. Now, this one's a little bit different. What are the x-intercepts here? Remember, the x-intercept is something that will make this whole thing equal 0. So this x right here, if that was 0, isn't 0 times anything just 0? Well, 0 times negative 8 is definitely 0. So that's one of our x-intercepts right here. And what would this x have to be in order to make this guy inside here become 0? X would have to be 8. See how that works? So if this was 8, that'd be 8 minus 8, that's 0. 0 times 8 out here is just 0. It makes the whole thing 0. So these are our two answers. We have two x-intercepts here. Let's prove it. Let's push y equals and then clear. And type in x squared, just like you see it, minus 8x. Let's graph it. Okay, let's see if the two answers that we got are right. Let's push trace. And, well, I didn't even have to type it in, it's already there. X equals 0, y equals 0. This is our x-intercept, but there's more than one. We found the number 8 to also be our x-intercept. So x equals 8. Sure enough, y is 0. It's perfect. And it's flashing exactly on the spot. Those are our two x-intercepts. Okay? Let's keep going. How many more do we have? Oh, this is our last one. That's cool. I wonder why there's this one. I'm not sure. I forget why I wrote it in here. Maybe there's something special about it, but we'll check it out. Okay, I'm factoring it right now. Notice I didn't have to factor anything out from the very front. It's just already done for us. 4 times 5 is 20, but that doesn't work to get a 3. So what else makes 20? 10 times 2? That's not going to give us a 3 in the middle if we add it up. What else makes 20? 4 times 5, 10 times 2. Oh boy. Guess what, folks? I can't think of anything that works here. So I'm going to take the graphing calculator and show you what's going on. This thing, I can't think of a number. There's nothing that works properly here. So I'll show you the dilemma. Let's do it on the graphing calculator. Alright. Push y equals, clear. Let's go x squared plus 3x. I'm glad I had this example on here because sometimes they give you a question like this and you'll be stumped. You'll be like, there's nothing that multiplies to make 20 and then adds together to make 3. How come it didn't work? X squared plus 3x plus 20. Oh, I know why. We're going to have to zoom out here. I'm going to zoom out so you can actually see this thing. So I'm pushing zoom out, then I hit enter. Okay, there it is. I don't know if you can see this properly. Do you see any x-intercepts whatsoever here? I am sure I'm hearing you right. You are saying, no, there's no x-intercepts. The vertex of this parabola is right here, and the graph is going upwards, so it never cuts through the x-axis at all. So this thing does not have any x-intercepts. So there are no x-intercepts here. None. Okay? No x-intercepts. Okay, and that's why there was nothing that we could think of that multiplied to make 20 and add to make positive 3. Okay, I think that's an acceptable answer for this course. If I'm wrong, I will come back and talk about it later. Alright? That's a long enough video for now. Good for you for listening.